Good morning, everyone, and happy Monday. Today we are looking at the concept of kinetic energy. So last time we had potential energy, which is the energy due to the position of an object. We also said that there is elastic potential energy and that you would cover that more in Physics 20. We're also going to take a sort of a quick look at a picture with it today. But kinetic energy, instead, this is the energy of motion. Okay, and so here I can show you, for example, different forms of energy. So here you're going to have the biker who is putting in some kinetic energy as he's going up the hill. And then when he's at the top of the hill, he's not moving, and due to his position on top of the hill, he has potential energy. And then when he comes down the hill, because again we're moving, so it's energy of motion, we're going to have kinetic energy. Then we have someone else here on top of a staircase, let's say, and she's holding a ball. So at that point, the ball has potential energy because of its position high up. And then when she drops the ball is going to have that kinetic and potential energy transformed into kinetic energy or energy of motion. Okay. Another example. Here we have somebody who is drawing on an arrow, a bow and arrow. And again, because of drawing on the bow and arrow, what we have is we have some potential energy here. And then when the arrow is fired, then what we do have is we have that energy of motion of the arrow, and therefore we have that kinetic energy. Now, kinetic energy is dependent on two factors. The mass of the object, and we know that that has to be in kilograms, and also the speed or velocity. If it has a direction, is fine. We can also use velocity of the object, and that has to be in meters per second. Okay, so when we look at our formula for kinetic energy, we get EK, so EP, remember, was potential, EK is kinetic, is 1/2 mv squared. So that is the formula for kinetic energy, where EK is kinetic energy, and it's going to be in joules, right? M is the mass in kilograms, and V is the speed in meters per second. All right, so let's have a look at how we would use this formula. And so we'll start with some easy questions, and then we'll go from there. We'll see what else we can do with it. So it's just a simple plug and play. So example 1, an 8.00 kilogram mass moves at 20.0 meters per second. What is the kinetic energy? Of the mass. All right, so EK, 1/2 mv squared, so 1/2 or 0.5. Oops, that one was 8.0 kilograms, and we have our speed is 20.0 meters per second squared. Okay, so make sure that if you're using a scientific calculator that you are using your brackets for this one. Okay, if not, if you don't have a scientific calculator, then what you want to do is you want to do the 20 meters per second squared first, then times it by 8, and then times it by 0.5. And so here the answer is going to be 1600 joules. We need our answer to be to 3 significant digits. And so either 1.60 kilojoules, so I can divide by 1,000 and get my answer in kilojoules, or I can do it in scientific notation, 1.60 times 10 to the 3 joules. Okay, let's try a different question. So this time we're going to have one where we're solving for, let's say, mass. So example 2. A bullet is traveling at 3.0 times 10 to the 2 meters per second and has 2.0 kilojoules of energy. What is the mass of the bullet? Okay, a reminder to try and pause the video and see if you can solve it on your own. We can write down our variables here, what we're given. So 2.0 kilojoules is 2,000 joules, and I'm looking for the mass. So EK equals 1/2 mv squared. So I have to get the m by itself. That means I'm going to divide by 1/2, so that cancels. I got to divide by v squared, so that cancels. And then whatever I do to one side, I have to do to the other. So therefore, my formula for m is EK divided by 0.5 and then divided again by v squared. So 2,000 joules and here we have 3.0 times 10 to the 2 squared. All right, so divide 2,000 by 0.5 first, and then divide again by 3.0 times 10 to the 2, or 300 squared. And so the answer here you're going to get is 0.044 kilograms. Okay, and we want the answer to 2 significant digits, so I could leave it at that. Or if that's like, oh, that's a really small, well, you could say, okay, that's 44 grams. That's how much the bullet weighs. Okay. Or you could write it in scientific notation. Scientific notation, 4.4 times 10 to the negative 2 kilograms. Those are all possible answers for that question. Okay. Our third example, we're going to solve for speed. So we have a rocket with a mass of 2.00 times 10 to the 2 kilograms, has a kinetic energy, so it is moving, it has a kinetic energy of 1.0 times 10 to the 3 joules. What is the speed of the rocket? Okay, and I'm going to give you the answer. You should get 3.2 meters per second. So hopefully, again, you can pause the video, try it out. So let's see, we're listing what we're given, the mass, and the EK, and we're looking for V. All right, so again, our formula EK is 1/2 mv squared. I want to have V by itself, and so the first thing I'm going to do is I'm going to divide by 1/2, so that cancels. I'm going to divide by m, so that cancels. And so whatever I do to one side, I have to do to the other. So V squared is EK divided by 1/2 and by M. But I don't want V squared, I want V. So what is the opposite of a square? It's a square root. So I need to square root that so that this and this cancels. And then whatever I do to one side, I have to do to the other. So V is equal to the square root of EK divided by 1/2 and M. So when you're putting in your calculator, do EK divided by 1/2, divide it again by M, use your brackets if you need to, and then once you're doing that, then do the square root, okay? And so here the answer, 3.2 meters per second. All right, now the last example we're going to do is, what about if we have to do one more step? What if we are missing one of our pieces of information? So let's do example 4. A ball rolls from point A to point B in 15 seconds. The distance between A and B is 25 meters. The ball weighs 2.00 kilograms. What is the EK of the ball? All right, so I'm going to write some stuff down. So EK is what I'm looking for. I have the mass. And I'm looking for V, and EK is 1/2 mv squared. So I don't have V and I don't have EK. I'm looking for both. So I have to have a way to find V. Now, in order to find V, we've learned that we can find V by doing delta D over delta T. Do I have delta D? I do. 25 meters. Do I have delta T? Yes, 15 seconds. So the very first thing I'm going to do then, my step number 1, is going to be V is D over T. So 25 meters, 15 seconds. So the speed of the ball is 1.67 meters per second. Now I can do step 2, which is this formula right here. And so EK is equal to 1/2 M, and then that number squared. When I look at this question, I have 3 significant digits here, I have 3 significant digits here, but I only have 2 right here, and therefore my answer needs to be to 2 significant digits. And so 2.8 joules is the answer there. Okay, so that's kinetic energy. I'm going to give you guys some questions on that as well. But one thing that we need to move on to is the law of conservation of energy. And we had this one before, remember? We said that energy cannot be created nor destroyed. It can just transform from one form to another, or it can be transferred from one object to another. We saw that earlier when we did potential energy. So then, when it comes to kinetic and potential energy, I showed you right here in these examples that we had kinetic energy of the biker going up the hill becoming potential energy when the biker is at the top of the hill not moving, and then again becoming kinetic energy when the biker is down. Or again, potential energy of the little girl holding the ball above ground, and then that ball falling down and picking up kinetic energy, transforming into kinetic energy. So when it comes to the law of conservation of energy, the way that it sort of translates to our formulas is that at any given point, EP is equal to EK. So whenever you have the ball at the top of the cliff, at the top of that platform, it has a certain amount of potential energy, and then when the ball drops, it is transformed. The same amount of energy is transformed into energy of motion. So here, I'll give you an example of how we would use this formula. And we can also expand it. EP, don't forget, is mgh. Mass, the acceleration due to gravity, and the height, and then 1/2 mv squared. So those are the two formulas, right? So those two things are equivalent to one another. They're the same. And so if we have, let's say example, a cliff diver has a mass of 75 kilograms. He is standing 30 meters above the surface of the water. What is the speed of the diver just before he hits the water? Okay. So what can I do with this? Well, I have mass, I have height, and I have the acceleration due to gravity. So I could find my EP, and then since EP equals EK, then I could use the number right here to try and figure out my speed over there. So let's have a look. Let's write some things down. So M, 75 kilograms, H we said was 30 meters, G is 9.81 meters per second squared. That's the acceleration due to gravity, and it's always a constant. So our formula is EP is equal to EK, or MGH is equal to 1/2 mv squared. Okay, so let's do this side of the equation. So I have M, 75, 9.81, and 30. And then 1/2 M, 75, and I'm looking for V squared. Or I'm looking for V, I'm left with V squared over there. So when I do this whole thing right here, when I do this calculation, what I end up with is 22,072.5 joules. I'm just gonna keep that in my calculator. And then we just figure it out in the question above, that if I'm looking for V is equal to the square root of the energy divided by 1/2 divided by 75. And so when it's all said and done, 22,072.5 divided by 1/2 divided by 75, when I do the square root of that, I get 24 meters per second. And there you go. Okay, I'll give you another one, exactly the same idea. Try it on your own, example 2. So a 70.0 gram bullet is shot out of a rifle straight up in the air. Using 4.00 kilojoules of energy. So 2 what was the speed of the bullet? And B, how high did the bullet go? Okay, so here, V EK 1/2 M, square root of that. So I have 4,000 joules, 1/2, and 0.07 kilograms, right? 70 grams, I have to divide that by 1,000. So 0.07 kilograms is the weight of the bullet. And so the speed of the bullet is 338 meters per second. And then, so this is the answer for A. For B, this is when we're using that EP is equal to EK. So if my EK was 4,000 joules, then my EP is 4,000 joules. Okay? So then, EP is mgh. I'm looking for H, so EP divided by M and divided by G should give me the H. Okay, manipulating the formula there. 4,000 joules divided by 0.07 kilograms, and then again, 9.81 meters per second squared. And the bullet went 5.82 times 10 to the 3 meters high, or you could say that it went 5.82 kilometers in the air. Okay, so that's how you would use the EP, the conservation of energy. EP equals EK. Okay, and okay, let's get to the next page. Now, there's also the idea of mechanical energy. Since we're using so mechanical energy is defined as the energy due to motion and the position of an object. So mechanical energy is the energy due to the motion and position of the object. So the fact that I'm using that word "and" should give you sort of a hint that when it comes to the formula for mechanical energy, which is EM, since we're saying "and," it's going to be our EP plus our EK. So our potential and our kinetic. And so we could also say mgh plus 1/2 mv squared. Those are our formulas. And a simple question on here, I'm not going to dwell too much on different kinds of questions here. So a 0.300 kilogram baseball is thrown at a height of 2.50 meters above the ground. And a speed of 20 meters per second. What is the mechanical energy of the ball? Okay. And I'll give you the final answer here as well, just if you want to pause. And so EM, we have 1/2, oops, we can do it, it doesn't matter, mgh plus 1/2 mv squared. So we have 0.30, 9.81 meters per second squared, and 2.50 meters plus 1/2, 0.300 kilograms again, and 20.0 meters per second squared. So when I do that whole first part, I given 7.3575. I'm just going to keep it all in my calculator, joules. And when I do 1/2 mv squared, I get 60 joules. And so to 3 significant digits, I should get 67.4 joules is the answer for the mechanical energy there. All right. And then one last thing that we need to cover when it comes to energy, and I'm sure you guys did this in junior high. So one last concept that we need to cover for energy is efficiency or useful energy. So being able to calculate the efficiency of an appliance or the efficiency of a device is a good thing. We know that when it comes to energy, a machine converts an initial energy added, what we call an input, into different types of energies. However, not all of them, of those energies, are useful to do work. So we say some are useful energy, or we say like work output, right? So if I'm putting electrical energy into my light bulb, I want light to come out of it. That's the work that I want the light bulb to do. But we know out of the second law of thermodynamics, the second law of energy, the first one was energy cannot be created or destroyed. The second law of energy says to us that no energy conversion is 100% efficient. The second law of energy says that no energy conversion or transfer is 100% efficient. Some energy will be lost. Okay? And we call that sort of waste energy, also known as entropy. Okay? So some of that energy will be lost. So for example, the light bulb, yeah, some electricity is lighting the light bulb, but also I'm losing some of that energy as heat as well, because the light bulb does heat up. The higher energy, the LED lights that we have today, they're higher energy and higher efficiency because they don't get hot. We don't have that energy loss due to heat, okay? So that's that second law of thermodynamics. So how do we figure out then the efficiency? What is efficiency? So efficiency is how much of the energy input is converted to useful energy or work, because we want the device or the appliance to do something for us, output. So for that, it's going to be calculated in percentage. And so we have a formula for that as well. So efficiency, or sometimes percent efficiency, is equal to useful work output divided by total energy input times 100. Or useful energy output divided by energy input times 100, okay? Let's look at an example together. So calculate the efficiency of an engine that consumes 3.50 times 10 to the 3 joules of energy to do 2.30 times 10 to the 3 joules of work. Okay, so percent efficiency, my output divided by my input times 100, and the 3 significant digits. This engine is only 65.7% efficient. Okay. What about if I was doing some manipulation of the formula? Calculate the work done by a machine with an energy input of 1.20 times 10 to the 4 joules and an efficiency of 35%. So not a very efficient machine that we have here. So the first thing, I'm going to write down my percent efficiency, output, input times 100. Okay. And so percent efficiency, so if I have times 100, what I want to do is I want to start with that 35% and I want to divide it by 100. So I get 0.35 is equal to output over input. I'm looking for the output, but I have the input. Okay. And so 0.35 times 1.20 times 10 to the 4th is going to give me the answer. So it's the same thing here as if I pretend if I'm manipulating the formula. I'm going to write it on here. So 0.35 equals x 1.20 times 10 to the 4 joules. Okay. So how do I get x by itself? I have to multiply by 1.20. If I multiply by 1.20 times 10 to the 4, then this one and this one cancels, and x is by itself. Whatever I do to one side of the equal sign, I have to do to the other, right? And so that's how I get x. So back to black ink. 0.35 times 1.2 times 10 to the 4. I'm going to get 4,200. Okay, so 4.2 times 10 to the 3 joules, or 4.2 kilojoules of output. That's how much work that machine is doing. Okay. So that is it for physics. That's the end of the physics unit with the energy piece. I'm going to be giving you guys just a worksheet on kinetic energy. A couple of questions, might be one on mechanical and one on efficiency. And then on Wednesday, you guys are going to have your final physics assignment, okay? And we will see you tomorrow for a Google Meet. Make sure that if you do have any questions that you bring them then. See you then.